All right, good day. I hope that you're doing good. So in this video, we're going to be going through the solutions for the practical, right? Specifically for the calculus practical. Now, starting off with question 7, or before I start off with question 7, I want to emphasize the point that these questions are from your previous prelim question papers. Now, question 7, 7.1 requires us to derive this, right? Minus 2x squared using the first principle. Now, let us go about doing that. First, you will plug in your first principle formula, which is there at the back of your question paper, all right? Then you substitute f x plus h, right? This simply means where you see your variable x, you substitute it with x plus h minus the original f of x. Now, let us go about doing that. Now, when we substitute everything, we have minus 2 brackets x plus h squared minus, right? And then in brackets, the original f of x formula, which is minus 2x squared, right? Now, the first or another step that we need to do is that we need to distribute, or rather simplify this x plus h squared, all right? Before we can distribute these two into the brackets. Now, first we start by simplifying the brackets. From there, we distribute the two. And also we multiply this negative into this bracket, all right? Now, let's go about doing that. Now, if we distribute this bracket, we're going to have x squared plus 2xh plus h squared. And then here we said this negative is going to multiply with this negative. Then we're going to get a positive value, all right? From here, we distribute these two into the bracket. So we will have minus 2x squared minus 4xh and minus 2h squared plus 2x squared. And remember, everything divided by h, right? Now, when you get to this step, right, most importantly, what you need to know is that your values which do not have the variable h would have to cancel out one another. And now let me show you what I'm talking about. Can you see here we have minus 2x squared? It doesn't have the variable h, same way as this minus 4xh has. So this, I'm expecting it to cancel out with something else. And in this case, it's going to cancel out with plus 2x squared. Now, you must be left with only variables, right, or values which have the variable h. Now, I'm left with minus 4xh minus 2h squared, all over h. Now remember to always write this, right? Your limit as h approaches 0. So this is what I'm left with, right? And now when I arrive at the step where I'm left with only values which have the h variable, I need to take out a common factor of h so that I can eliminate this h which is in the denominator. Now let me go about doing that. Now if I take out the common factor which is h, right, and h is present on both these terms, I'm going to be left with 4x minus 2h, right? And these two are going to cancel out one another. Simply means that my limit as h approaches 0 is going to be 4x minus 2h. All right. And now when you get to the step whereby only one term has the variable h in it, you can then substitute 0 where you see your h. So in this case, I'm going to say 4x minus 2 multiplied by 0. And then my final answer is going to be equals to 4x. Right? Now, this is all for 7.1. Let us move on to 7.2. 7.2.1, we're still on the derivatives, right? We're still solving for derivatives. They say now we need to solve in terms of dy over dx, right? Now, if they say if my y is equals to 2x squared minus 1 over the root of x, right? I need to find the first derivative of this. Now, what is the first step that I'm going to apply here? Now, the first step I'm going to try to remove this z, or rather simplify it, because whenever you're deriving, you do not want to deal with roots. So make sure that the first step, whenever you have this kind of questions, you first try by removing the root, right? Or simplifying the whatever variable that has a root. Now, in this case, this is the same as x, right? To the power 1 over 2, right? Now, second step, right? After I've just simplified this, or rather remove the square root, can you agree that this is the same as 2x squared over x to the power 1 over 2 minus 1 over x to the power 1 over 2, because both these terms on my numerator have a common denominator, which is x to the power 1 over 2, right? Now, I'm going to separate these two terms. Now that I have separated this, right, into two terms, right? Now, I have a common variable, which is x, both on my numerator as well as on my denominator, right? Now, because these two are dividing one another and they are also the same, I can apply my laws of exponents in terms of dividing terms which are the same, right? Now, because these two are the same, I can what? I can retain the term which is x and subtract the exponents. Why? Because these two are dividing one another. What I'm saying is that, okay, this is the same as 2x. Now, we retain the term and subtract the exponents. So my exponent is going to be 2 minus a half, right? And this minus this, right? 1 over x, right? Remember your 1 over x, it is the same as x to the power negative 1, right? Now, meaning that also this is the same as x to the power negative 1 over 2. All right. Now, the aim is to make sure that these terms, now after we have separated this fraction into two terms, now you want them to be in the standard form, right? And now if they are in the standard form, it will be easier for you to derive them. All right. Now, 2 minus a half, punching it into your calculator, you will get 3 over 2. So this is going to be the same as 2x to the power 3 over 2, right? Minus, this is a 3, minus x to the power negative a half. Now from here, let us derive this. So I'm going to take this exponent and multiply it by this 2, right? So it's going to be 2 multiplied by 3 over 2, and this is going to be equals to 3. From there, I need to subtract 1 from this exponent. So this is going to be 3x all over 1 over 2. Now, I have to apply the very same steps on this term, right? I'm going to take this negative a half and multiply it by, remember here it's an invisible 1 and it is multiplied by a negative. So basically here it's a negative a half multiplied by negative 1, right? So this is going to be positive a half x, and remember I need to subtract 1 from this exponent. So negative a half minus 1, punching it into your calculator, it should give you negative 3 over 2, which would be your exponent in this case, right? And this is your final answer, which is 3x to the power 1 over 2 plus 1 over 2x to the power negative 3 over 2, right? Now let us move on to 7.2.2. Now, with regards to 7.2.2, we need to find the first principle of this, 3x minus 2 squared. Now, the first step is to try and simplify this, right? Basically distribute this squared by doing what? By saying 3x minus 2, right? But remember it's squared. So this is the first step. We're going to try and remove the squared or distribute the squared. From here, we're going to multiply these two brackets, right? And after we have multiplied these two brackets, we would have a quadratic equation. From there, that is when we can start applying our first principle, or rather we can start applying the derivative law. Now let's go about doing that. Now, if you multiply this 3x with this 3x, right? So you're going to get 9x squared. And then this 3x multiplied by negative 2, you're going to get negative 6x. This negative 2 multiplied by 3x, you're going to get negative 6x. And then this minus 2 multiplied by minus 2, you're going to get positive 4. From here, if you simplify this further, it's going to be 9x squared minus 12x plus 4. Now, let's derive this. So we're going to take this 2 and multiply it with this 9, and it's going to be 18x. Now, remember, we need to subtract 1 from the exponent. So it's going to be 18 to the power 1, right? So you can just leave it like this. Now, the derivative of this is going to be minus 12. And you know the derivative of a constant is always 0, right? So this is the same as plus 0. Now, this should be your final answer. You could just write it down as 18x minus 12. This is the first derivative of 3x minus 2, all to the power 2, right? Now, let us move on to 7.3. Now, 7.3 says prove that the gradient of the curve is a negative at each point on the curve where x is greater than 0. Basically, remember, whenever you're dealing with gradients, right, it simply means that we need to make use of the first derivative, right? Because the gradient of anything, remember, your first derivative is the change, right? It's changing something. And this also represents your gradient. So every time whenever you have a question relating to gradient, just know that you would need to make use of the first derivative. Now, how are we required to make use of that in this question? Now, we need to prove that the gradient of the curve is a negative, right? Meaning that at each point whereby our x is greater than 0, the gradient should be a negative. Now, we're going to first find the first derivative of this, right? And after finding the first derivative of this, we know that whenever you substitute any point which is on the graph, right? Any x value which is on the graph, you should get the gradient at that point. So basically, whenever, in this case, we need to substitute any x value which is greater than 0 or any x value which is a positive value, right? After we substituted that x value which is a positive value, we need to find our gradient as a negative. Basically, your final answer should be a negative irrespective of what positive value you substitute. Now, in order for that to make more sense, let us go about doing that, right? Let us start by first finding the first derivative of this 1 over x squared. Now, first, I'm going to change this to be in standard form. Now, this 1 over x squared is the same thing as x. Okay, let me just write it here. To the power negative 2. From there, when it's like this, it's easier to derive, right? Because this is going to be minus 2x. And remember, here we need to subtract 1. So this is going to be minus 3. So this is the first derivative of y is equals to 1 over x squared. Now let's try to put this to be in a form of a fraction. So if we do that, so we know that this is going to be the same as, first let us put this negative, right? Okay, let me put an equal sign here. So we're trying to put this to be in a form of a fraction. So this negative, now this is going to be your numerator, 2 all over x to the power 3. Now this 3 is a positive value, right? Now we have found the first derivative, and now we have written it in a form of a fraction. Now, how are we going to make use of this first derivative? Now we said your first derivative is an equation of a gradient, right? And then basically, if you substitute any point on the graph or any x value on the graph, you will get the gradient at that point. Now here we're saying that we need to prove that if we substitute any x value, which is a positive value, the answer that we would get as our gradient here, it's always going to be a negative. Now, so can you see here you have negative 2 over x to the power 3. Now, if you substitute any value which is greater than 0, it can be 1, it can be 2, any value which is greater than 0, do you realize that you would get a negative value, right? Because of this negative which is outside here. So your positive, your fraction would be a positive value, but remember it's multiplied to a negative. Now from here we can conclude that, okay, our first derivative, dy over dx, it's always a negative. So it's going to say this is always less than 0, right? Every time we substitute an x value, which is a positive. Now I can say for x, it's greater than 0. So basically you were saying, okay, our first derivative here would always be a negative every time we substitute an x value, which is a positive. And remember, this first derivative represents your gradient.